Hi everyone, welcome to the day 2 of Power Forecasting Online. In this very first session, we have the pleasure to invite Matthias Lange, CEO, and Varun, Executive Vice President at Energy and Meteor Systems, to share a presentation on Skycams. Please note that following this session will be the final and a great panel discussion on power demand and forecasting tools, which you may join in from its separate Zoom link. But for the time being, it will be a super interesting dive into the world of Skycams and optimization of solar power forecast. And if you have any questions for Matthias and for Varun, please make sure you post them into the Q&A box at the bottom of your screen so they may answer you at the end of the presentation. Now, without further ado, I would like to invite Matthias and Varun to your presentation.
Yes, hello. Thank you for the introduction. I hope everyone can hear me. If not, please put this into the chat. So our presentation today is on Skycams and their benefit for solar power forecasts. So solar power forecast in the short term. Thank you. Of course, whether it's a breakthrough or not, we'll see. I mean, it's also up to you to look on that. Basically, the idea is really to use this as an example to put in more sensor data, more data from the outside world, more live data to forecasting, to power forecasting. So forecasting, which is used in the energy market. Just let me get this next slide. Yeah, so we will start with a short company profile so that you know what we're doing. I will introduce you to Skycams to show what is the principle, what are some basic results, show why we think that benefits or that there are benefits of Skycam data in solar power forecasting. And Varun will then give you some ideas on the pilot projects that we have and the lessons that we've learned so far from this technology. Yes, but so we as a company, we have this vision of 100% renewable energies in the electricity supply. This is what we've been following for many years now. We wanted to support this with the services that we have. And we started in 2004 with Energy Meteor Systems. We have split up this company into 3 companies 2 years ago. But the idea is to provide services for integrating renewable energies into electricity markets. So for traders, for example, and electrical grids. And the major service we're talking about today is forecasting of wind and solar power. What we also have is virtual power plants, which is more software for decentralized energy systems. We provide software for grid operators to handle redispatch processes of renewables in the grid, and we offer some consulting. As you might have thought or guessed, our main customers are customer groups, energy traders, grid operators, and to a small amount plant operators. And we do this worldwide. So this is an overview about the countries where we have active forecasting at the moment. You see there's a major part in Europe. Just let me see this laser pointer here. So we have forecasting Europe, the United States, South America, and also India is a large market for us where we have a high market share. And I not only show you this to see, to give you an impression that we are very international, but also to give you an idea that we work in different climatic zones, which is also important to estimate the benefit of the Skycams and the solar forecasting. Yeah, just solar forecasting means that we want to predict the power output of solar plants in the future, the near future, next 15 minutes, next 10 minutes, next hour, rest of today, tomorrow. So to get a production schedule of these plants so that, for example, energy traders know what they can bid into the market and also react to changes in the production. That's why we update our forecasts on a regular basis. And the problem in solar power forecasting is that everything between the solar module, so the modules here, and the sun everything that is in between is a bit nasty. So it has to be forecasted, and this is the real challenge. So on this nice looking picture, we see broken clouds, and they're difficult to forecast because, for example, weather models do not see individual clouds. Only a very recent ones are starting to really look into the details of these clouds. So this is one of the basic issues that we have to face. Our customers expect exact forecasts of clouds, but weather models do not see them. So Skycams will be one technology to remedy this to a certain extent. The idea is quite easy. Look at the clouds. What is important is that what is important is that the clouds are not the relevant objects, but the cloud shadow, because that is what defines if there's a fluctuation in the solar power output. So we want to calculate these, or to know about these shadows. We want to observe them, and this is of course possible in a very classical way with a satellite from above. But you see, what one basic shortcoming of satellite is that it is far away, and it looks from the sky onto the clouds, so it sees the surface of the clouds. It does not really see the cloud shadow. Whereas a Skycam is a camera that is normally implemented close to the site, close to the solar plant. It looks into the sky, so from the perspective of the plant. So all this geometrical stuff about sun, cloud, and so on is automatically cared for. And if you have many clouds, then it's easier to assess the cloud situation, the shadows on the ground with Skycams compared to satellites. The disadvantage is that you have to install Skycams first close to the site, whereas satellites are normally, or satellite images are available and covering most of the Earth's surface. So the availability of Skycam data is at the moment a bit limited. But it would be nice to have more of these Skycams available to detect and track clouds by observing them, and then go one step further, propagate the cloud shadows in space to look into the future. So just assume there's a certain motion of clouds in one direction, and then you just extend this into the future by just shifting the cloud field, and then you have an idea what the fluctuations will be in the future. That's the very simple idea of using Skycams in solar power forecasting. And this works quite well. Just to give you an idea how solar power forecasting works, we have here some ingredients on this left-hand picture here. We need numerical weather prediction data, we need data from the plants, and we need some additional information like satellite images. And we put this together, get a forecast of the future power output. So what is state of the art is to use multiple weather models, to use satellite images, and to use real-time power data, measurement data from the plant. And this gives quite a good forecast at the moment, but with Skycams either in one location, so close to this plant you want to forecast, or in a network of Skycams, so that you have a kind of overview what's going on in a certain region. You can add additional data that gives a large benefit to the forecasting accuracy in the first 15-30 minutes, so in the shortest term, as we call it. This is a Skycam. It's a very it's a very technical device that is just a certain type of camera looking into the sky. This is the area where we are. Oldenburg is in the northwest of Germany, where we have this first implementation. So it's we had our first contact 4 years ago with Skycams in our R&D project, and this is where we've learned a lot about this technology and where we did the first efforts to improve our shortest term forecasting. And we used a network of several Skycams. Or the advantage is that we can then follow cloud shadows over a longer time. So it's not strictly necessary to have these many locations and this network of Skycams, but it's good. It makes things easier. What you need is normally 2 or 3 Skycams at your position. Okay, so here on the left-hand side, you see the cloud shadows moving. So this is just a lat long plot, so just the geometry close to a PV plant, a solar plant, which is located where the red spot is, and the dark or the blue areas here are cloud shadows, so low irradiance, and the green spots are high irradiance, so a lot of sun and not so much sun. And this leads to fluctuations. As you see here, this is 1 day, obviously, of solar production. 2 lines. The black line is what really happens, so what the plant sees as a power output, and the red line is what is calculated in terms of power if we convert this irradiance into power. So it should be basically the same. It's nearly the same. You see this also in this zoom here downstairs in this lower plot. So this is the sort of the situation as this cloud field or the shadow on the grounds move across the location. And now in this technical plot, you see the main idea of this, because everything that is left from this vertical blue line is the past. Then we have here the future. And the idea is to have more data from the plant than just the measurement up to the point of time where you want to produce a forecast. So at this position now, we want to have more information about the future than just the recent measurements. And this green line is called a power Skycam nowcast. So we shift the cloud shadows into the future, and then we see the future power production. So this is the green line. It's just a kind of measurement of the future. And then we use this to connect it with our forecast, which is this dashed green line here. This is the power forecast. And as we are we have more information about the future than in our normal forecast, which is the blue one, we have a better forecast. So this is the benefit of the Skycam. We are able to look into the future by 15 minutes or 30 minutes, depending on the setting. And this is what sort of avoids large forecasting errors in the up to 1 hour ahead. So although we just have this additional data for, let's say, 30 or 15 minutes into the future, the effect on the forecast is about 1 hour. So the positive effect on the forecast is about 1 hour. So that's the major benefit. And if you then evaluate this over longer times, you see that you have about 20% improvement in the forecasting error. So it's more accurate if you use Skycam data in this time frame compared to not using it. And this is why we think it's very important to use this for certain kinds of PV plants. And this is what Varun is going to tell you now.
Thank you, Matthias. Good afternoon, everyone. I hope you all can hear me. In my slides, in my subsequent slides here, I would present our pilot projects on Skycams in some parts of the world. More precisely, I would discuss the use cases of Skycams that we had in these pilot projects. Then I would discuss briefly the strategy that we used in integrating Skycams into our forecasting chain. And lastly, I would talk about the challenges and lessons learned from these projects, which are also helping us in further technical advancements in this technology. Next slide, please. Yeah, thank you. So talking about the background of the pilot projects, there are a lot of use cases of Skycams, but we chose India and Arabic Peninsula for our pilot projects because of some reasons. For example, in India, we have a lot of ultra big solar power plants in western part of the country, which pay significantly high penalties because of the forecast errors. And they are very keen to explore technologies like Skycams to reduce these forecast errors. Yeah. In Arabic Peninsula, we also have a similar situation where there are a lot of ultra big solar power plants, and forecast errors here have a high impact on the grid functionality. So they are also looking, they are also in a lot of pressure from grid operators to explore new technologies such as Skycam. So we are carrying out pilots of our Skycams in these two countries, in those two regions. And for this trials, we are tied up with an European Skycam solution provider and local solar IPPs in these two locations. Next slide, please. Talking about the project execution for these trials or for Skycam projects, the first step involves installation of Skycams in different parts of the park and their calibration with the local weather stations at the park. Now, the number of Skycams required per park depends on the size of the park. The bigger the size of the park, you may need more number of Skycams installed at different locations of the park. Now, once the Skycams are calibrated and trained, they start generating pixel-wise irradiation forecast map of the area of your interest. And this is fed as an input into the power forecasting system. But before that, there are some steps that power forecasting system does. For example, plausibility checks of the data which is coming from Skycams, checking for corrupt data, filtering out corrupt data, etc. In addition, the system also does some post-processing of Skycam output. For example, calibrating the Skycam output with respect to the power measurements of the power plant. Yeah. So carrying out this process, the power forecasting system creates power forecast using the Skycam inputs. Now, the last step in this, the last work package is comparing the forecast generated using Skycams vis-a-vis forecasts which are generated by regular means, for example, using NWP data and statistical model. So we are currently in this, part of the project, and we are evaluating the performance of Skycams. Next slide, please. Now, during these the execution of these trials, we faced few challenges and learned a lot of lessons. One challenge is that we faced is the lenses getting dirty, because of bird droppings, soiling on camera lenses, or water droplets on camera lenses. So this situation happened very often, and it impacted the forecast from Skycams. So in this picture, you can see a situation where a bird is sitting on the lens of the camera, and sometimes making also lens dirty. Next slide, please. In this picture, you can see on the right hand side the clean lens, the picture taken by Sky camera, with the clean lens, and on the left hand side you can see the dirty lens. So with this picture you can appreciate that if the lens is dirty, it will have a significant impact on the output from Skycams. So this problem of lenses getting dirty and frequent cleaning was a challenge that we faced, and we are finding different strategies to cater to that. The second challenge that we faced was connectivity issues and data outages issue. So this project, the Sky Camera project, involves sending images from the Sky Camera to the forecasting system. And this involves a lot of data transfer happening, every minute, so several megabytes being transferred every hour, for example. And sometimes if there are connectivity issues, data outages issue, it has an impact on the project. So that was also a challenge that we faced in the project. The third challenge is the forecast regulations. So the Sky cameras, as Matthias presented in his presentation, could have a potential benefit on short forecast horizon, but in some markets or some countries, the forecast regulations could be such that it asks for forecast of longer horizon, for example, hour ahead or 90-minute ahead. And there the potential benefit of Skycam can get reduced. Yeah, so you also need strategies to cater to this challenge. Next slide, please. So learning from these lessons, we are currently working on some technical advancements. For example, we are working on some machine learning and AI modules on top of Skycam outputs. So here the idea is to use data and computer models to further improve the accuracy of the Skycam forecast, or making it more useful for longer forecast horizon. Yeah, so this is something currently we are working on. Secondly, we are working on the opportunity of combining Skycam based and NWP based solar power forecast in order to increase the overall accuracy of the forecast. And thirdly, we are also working on some advanced or automatic cleaning methodology of Skycam. For example, having a high pressure air jet around the lens, which was sending this high pressure air on the lens to clean it frequently. So these are some technical advancements which we are currently working on, and it is, I would say, one of the outputs of these pilot projects. So due to lack of time, I only presented very broadly our pilot project. But if some of you, if anybody of you are interested, we can discuss it bilaterally in more detail. Thank you. This is what I wanted to present. So there are some questions. I can see there are 2 questions here. Are these technologies easy to deploy? What's a realistic implementation time? Yeah. So Matthias, you want to take it or I take it?
Can you repeat the questions? I don't see them at the moment.
Okay. So the question is from Vasiliki. Are these technologies easy to deploy? What's the realistic implementation time?
Yes, so they are easy to deploy in the sense that we have a sort of procedure which worked very good for the pilot cases. And you have to carry the device to the site, and then you have to implement it and look for the data transfer. So this is very important. And the other one is that we are working on sort of, as this is still a pilot phase, on a more plug-and-play solution. But the idea is to make it easy, because we think that it is feasible for large solar plants, especially, for example, in India and other regions of the world with, for example, penalty system, or with large plants, like a few hundred megawatts per plant. And we want to make it feasible to get this installed at the site.
Good. And then there is a question, do you have a market in Bulgaria?
Yeah. Well, market, so we don't have pilot projects of Skycams in Bulgaria, but we can supply forecasts for the area. So yeah, I mean, we can supply forecasts for every point in the world, and also for Bulgaria.
And just want to add here that we are already working a lot in Eastern European region, and in the recent months and years, we have seen a lot of new interest coming from that region, and we are also very keen to work in this area. Then there is a question.
The specific plant economics. I mean, at the moment, it's a kind of fixed setup price for a plant. We don't have a fixed price list at the moment, but the idea is to have a setup price, and then, of course, to have some operation, because you need the data stream, we need maintenance at the site. So if you're really interested in the pilot project with us, just contact us, please, because it is a little, at the moment, as we are in this pilot phase with our first customers, it's still an individual project, but we have different ways of making or for realizing it. But the idea is really to deploy 2 or 3 systems at the site establish the data stream, and then of course put this into the forecasting process.
And last question is, okay, can you please walk us through specific plant economics of deploying these technologies in North Europe and
That's
California?
this is
clear.
what I just
Okay,
answered.
good. I think we have any other question? Good.
Yes, yeah, a good question here. The last question, the new market rules in India are not in favor of this technology, because if we shift from 90 minutes to 2 hours, or the shift to 90 minutes is at the sort of threshold at the in the range where we still see a positive effect from this Skycam technology, but not as large as 60 minutes or 30 minutes. So this is in my opinion, 1.5 to 2 hours from submission is too large to really benefit from the sort of the good accuracy of shortest term forecasts. So this new market rule in India is a bit counterproductive in this sense.
Good. I think, yeah, I think we have discussed all the questions. But if you have more questions, yeah, you have our email IDs. You can contact us. We can discuss it further.